This is problem 4 of function 8f(a)(4). We're going to determine the rate of change in initial value of a linear function from a description, a table of values, a graph. Then we're going to interpret the rate of change in initial value of the linear function in terms of the situation that they model. That being the case, let's look at our problem. Tracy planted a Monterey oak tree sapling in her yard. The graph below shows the height of the tree has changed over time. Let's look at the chart first, guys. Notice this says height of the Monterey oak. X-axis is the time in years. So at 0 years, we're here. At 1 year, that's the height. Okay, 2 years, this is the height. Over here is the height in feet. What is the initial value of the function? Let's see what we're looking for. So when we've got a constructed response, let's make sure we circle the things that we're going to be needing here. Let's make sure we number them so we do them. Let's go back and check. What's the initial value of the function? What does it mean in context of the situation? So first we want the initial value. The initial value is right here, is the y-intercept. Okay, now we're going from 10 to 20 here, so we need to figure out what this is. I've got 1, 2, 3, 4 tick marks to go 10 feet. If I divide 10 by 4, each one of those is 2.5. So this would be 12.5 feet. What's the initial value of the function? It's 12.5. What does it mean? So we got 1. What does it mean in context of the situation? Well, let's read it off the chart. At time 0, the feet is 12.5 feet tall. The tree is 12.5 feet tall. Okay, so time 0 would be when it's first planted, right? When the sapling, it's a small tree, when the sapling is planted, it is 12.5 feet high.